My name is Leon Farasati. I'm a staff product manager at Qualcomm Technologies. And this session is actually very interesting for me to MC because the platforms that you guys are going to see today are actually the ones that I work very closely with and I product manage. So this is very close to my heart. So I'm going to go ahead and introduce the session. But before I begin, let me go over a few housekeeping items. Number one, as much as we are a mobile company, we would like you to please silence your mobile phones out of respect for the speakers. I'd say mobile too many times. 10-minute breaks are scheduled at the end of each session. We want to stay on schedule, so please try to be seated before the session starts. I see you guys all did that already. And then there's a session survey form that is on the conference app. And if you do that, it gives you an opportunity to be one of the 14 winners of a 32-inch LG Smart TV. Drawings are going to be held in the Golden Gate foyer each day, Thursday at 5:30 p.m. and Friday at 5. Okay, so please do that. And so this is all I have for the housekeeping items. So let's get this started. So this session, as you all know, is the Ubuntu Linux on the Qualcomm Snapdragon 600 processor. And I'm going to introduce your speakers for today. So we have Marc Charlebois, Director of Open Source Software Strategy at Qualcomm Innovation Center. I work closely with Marc, and I'm sure you guys would love to hear from him. Also, Nicolas Duchesne, he's the landing team tech lead for Qualcomm Snapdragon processors at Linaro. So very happy to have him. And Kunal Patel, who is a technical lead at eInfochips. So with that, I'm going to hand it over to Marc.
Thanks, Leon. Welcome, everybody. Thanks for coming. So, actually, back to my first slide. Qualcomm has obviously been very successful with Android, has had platforms that run Android, and now we have several of our partners with Qualcomm Technologies that have these developer boards that are very interesting to the community, to hackers, to makers, but also to companies that want to provide additional products and even services and offerings on top of these boards. These are production-ready boards. And they've typically come with Android, but Qualcomm Innovation Center has recently joined Linaro and is working with Linaro to create a broader software ecosystem that will enable even more ability to customize and provide interesting solutions based on Linux. So you'll see at mydragonboard.org, that's where we have sort of the aggregation of all the different boards that are available, forums, places that you can ask questions, places that you can see either posts or some interesting projects that people are doing on the boards. So you can go there and that will be updated as new boards, new information is available. One of the boards I want to talk about today is the FC6410 from Inforce. And that's a board that is being used by Linaro to create a new Ubuntu offering. That offering is available today. And Nicholas is going to tell you a little bit more about the progress that they've made getting Ubuntu to run on the board. Let's see. What else? So in addition to Ubuntu now being available for the board, you can just fire it up like a desktop. It works very well, but that enables a lot of companies to take a standard Linux offering and be able to create a Ubuntu solution. But not only that, as you'll see from eInfochips, they've taken the enablement that's been created by Linaro and done something interesting even on top of that. So this again is building out our community so that we can have really interesting solutions that are basically being enabled by the work that Linaro is doing. So with that, I'll pass it off to Nicolas Duchesne, and he'll give you some background about Linaro and the work that they're doing.
Thank you. Hello, everyone. Is it okay? Okay, so as Marc said, I work at Linaro, and I'm going to take a few minutes to on stage. Okay. Sorry. I'm going to take a few minutes to introduce what Linaro is, and as Mark said, Qualcomm has joined Linaro. So Linaro is a very special company. So it's a not-for-profit company which is founded by members from the ARM ecosystem. The idea is that the ARM ecosystem is a complex ecosystem where there is a lot of common software to be written, and companies are joining Linaro to develop the common software, the foundation software, and to share the development cost and to make sure that software is written once. And also what's in the DNA of Linaro is open source, so the outcome and deliverables of whatever, all the components and all the work that Linaro is doing is the upstream communities that we are working with. So whether it's kernel.org, whether it's Android, GStreamer, all the community that we are working with, we want to upstream all the development. So, so in a sense, Linaro is working to improve the Linux on ARM solution, Linux in the open source software. So this is the picture that shows all the members from Linaro. So we started 4 years ago. Linaro was launched 4 years ago with 6 members, and we are almost now at 30 members. And Qualcomm is recently joined Linaro earlier this year. So that's the list of all the members we work with. Quickly, this is the organization at Linaro. So we are basically, we represent a workforce of 200 people, 200 software engineers that work across the globe. And we are split into several teams and engineering units. Some people focus on kernel and core engineering, kernel development, power management, virtualization. Some people will focus on a couple of products that Linaro is doing, like a stable kernel for ARM, validation framework. And there are also, we've created some engineering units that focus on specific market segments like enterprise, mobile, networking, and set-top box. So that's what you find at the bottom of the slides. There is also an organization called Member Services, which is basically where the work that we are going to talk today is happening. We work with each member of Linaro as a special team. That's what we call a landing team that works on something special for the member. So we work sometimes on our NDA, and then before we upstream, and this is a different working model. And what we've decided, and we have agreed to work with Qualcomm, is to help Qualcomm build this community or enable the development of the community around the Snapdragon. So our team inside Linaro is tasked to work on that, and that's what I'm going to discuss more today. So the idea is that, of course, there is no doubt that there are very good solutions, Android solutions for Snapdragons. This is for sure. The problem statement that we have seen, the 3 main issues that we have when we talk about going broader and to enable communities are the following. So the Android sometimes is not what people expect. And the Android user space stack is very good for many applications, but sometimes if you go to the embedded and to the broader market, this is not what people are expecting. This is the feedback we've got from vendors, and that's one of the issues that we are trying to address. The lack, the lack of standard components like GStreamer and X11, Wayland's, Qt5, which are very standard in the Linux world and which are missing in the Android space, is also a problem which has been identified. So that's also something that is going to be addressed. And finally, the development model of Android, where you have like a one-time kernel drop for one platform, and then you move to the next phone and the next generation of the chipset, doesn't really help the embedded space, where the market lifecycle, the product lifecycle is much longer, 10 years, 15 years, 20 years, and the code drop for 15 years ago is no longer to be good enough. So these are the 3 main issues that we have seen that as blockers to enable this community, and that we are going to try to address. So how? So the first thing that we are doing is what we call the Snapdragon Linux platform. So this is something based on Ubuntu, where we provide full-blown Ubuntu running on the Snapdragon 600 processors. We are also going to address the multimedia and graphics issue, whether it's Wayland, Qt, X11, GStreamer, hardware acceleration support to make use of all the capabilities of the platform. So that's items that we are working as well. And finally, in order to sustain and to get a long-term kernel support for the Snapdragon, working with the upstream kernel.org communities to get enough support in the mainland kernel so that we don't have to live forever with an old and ancient kernel. So as I said, So Linaro started to work on this, I think, 6 months ago, and we've made our first Ubuntu release by the end of May. So what this release, we've decided to use Ubuntu, and that was something we had identified, that Ubuntu was one of the most favorite distributions to be available, and Linaro was already using Ubuntu for many other products. So what we decided to do for Qualcomm is that we are going to we are making monthly release drops, images that you can download, and you get more and more features down the road. You have access to, by being Ubuntu, you have access to the entire Ubuntu repository, so everything which exists and which works on Ubuntu, whether it's a PC, whether it's a server, whether it's your board, is going to work as well on the Snapdragon 600 platform. We are working on as I said, the hardware acceleration support that requires firmware, so I'm going to talk about that. There are some special things to know about how we manage the firmware, so I just want to make sure, you understand that. The idea of this presentation is that to show you what we are doing and to give you the confidence that it is now easy to actually go buy a low-cost community board from the Qualcomm or the Snapdragon community and get started with embedded Linux. Then there is a little bit of details, but basically the way we work at Linaro, we always use the latest version of Ubuntu, which means that every 6 months you get a refresh. We follow the Ubuntu development cycle in April and October. We have monthly drops. Of course, you can go and download the release. You can report bugs if you find bugs. And this is an open source community where we use lots of mailing lists, public mailings, and chat. So if you want to get in touch with the people behind this stuff, I also mentioned how to get in touch with us over IRC. What does the release contain? So once the release is public, everything is public, you can get on linaro.org and download the release. So what do you get? We actually produce complete images that make it very easy to install and deploy on your board. The idea is that you should just download, run a couple of commands, and you should be ready to use your board. So there is no complex build instructions or nothing like that. Everything is available as working and completely full-blown images. So we release the boot image, which contains the kernel, the modules, and everything you need to actually boot the platform. And we release a couple of different system images. So right now we release 2 images, the developer image, which is a headless server type of image, which you can install and boot, and you have access to console and terminals and things like that. We also have released a graphical environment. We have chosen to use the Gnome, the Gnome shell. So I'm going to show that to you in a few minutes. But basically, what you get with this image is a full-blown desktop, exactly what you would get and you would expect to have on your laptop, for example. So the Snapdragon 600 is powerful enough to run all this software, as you can actually see later. So the images are meant to be flashed for the eMMC. That's very common on all these platforms, from MyDragon platforms, to have eMMC. It is not sometimes the most efficient way to work. So this is also possible to use like SATA drive, USB drive, or any kind of additional storage that you can hook up to the board. The support for the hardware acceleration is coming. We've started to work this year on this topic. So we have incremental release plans that are going to happen. We are going to support hardware acceleration for video decoders and video encoders and camera. That is going to happen soon. Finally, at the moment we are using the same kernel that is actually powering the Android device, so an old and ancient kernel. We are working to migrate to newer kernel because this is a typical requirement that we see when we start to address this market of embedded. People don't want to use and work with newer kernel. So yes, I said earlier, the proprietary firmware can be sometimes problematic. As soon as you get into a GPU, DSP, video acceleration, you need to actually use some of the non-standard core which are on the SoC, and they are running some proprietary firmware. It's actually not that difficult. Most of the board vendors will give you access to this firmware. They are released, from Inforce, or you basically have to get them legally, of course. And once assuming that you've got your proprietary firmware legally, we provide very simple and very straightforward instructions to get them on the board so that you can benefit from the acceleration. In fact, just to even show that, it's just 3 lines of shell script to actually do these things. So you can, once you cooked your firmware image with the simple instruction, you are ready to go. So How do you do that? You get the board, you download these files from the Linaro website, you have to flash these files, and then you just have to tell the board to boot. So that's exactly the sequence of things that you have to do to get started. Okay, and again, as a proof, this is the list of commands that you have to run if you want to get started. So what do you get? Once you run these commands, what do you get? You get this. So what is this? This is the Gnome shell environment. So this is, I don't know if you have ever seen Linux on a PC, on the desktop, that's exactly what you would get. And that's running on the board, on the ARM processor, which is available on the Snapdragon 600. So you can run, I think this is Firefox. You can do browsing, you can do file, you can look at your stuff. Everything which is working in Gnome shell is working. It's using the GPU for the acceleration. It's using the CPU for everything else. And everything, all the fancy composition that you expect from the regular desktop is just working on the Snapdragon 600 boards. So what can you do? You can also edit files. I mean, this is, if you are a developer, you can launch editors. And this is actually running on the board. Okay, this is very unusual. If you are not used to that, I mean, this is something maybe new, but that is actually running on the board. So you have a full desktop with a keyboard running on the board. You have Emacs or whatever you want it is. You can compile on the board. You can do pretty much anything you would do on your PC. So you can actually make your slides also. So you can install LibreOffice. On the board, it's available in the Ubuntu archive. As I told you, everything which is available in Ubuntu is going to just work on your board. So you can actually edit the slides for your next conference on the board directly. What you can do as well is you can play. So we have complete support for GPU, OpenGL, and OpenGLES. So again, this is a game which is available in the Ubuntu archive. It's the Super Mario Kart. You just install that from the Ubuntu Software Center, and you just run this application, and this is what you can do. You can play and as much as you want. Of course, I talked about embedded, okay? So, of course, if you are doing something which is embedded, you might wonder why would you actually do any Emacs or any LibreOffice on an embedded device. I was just trying to show what you can do with the platform. When you, if you target something which is more like on the embedded side of things, you want to use like a bare UI with just the X and optimized X server with full support for graphics acceleration. So that's something you can do. You will see that with the demo that is going to happen after my, my presentation, you will see what we can do with just like a bare metal performance. But basically, this is the raw X server which is running with no whistle and Bessel. There is no Gnome shell, etc. But you can actually run GLES or GL application and get the full performance of the platform. Of course, when you use Gnome shell itself is using a GPU, so you are actually wasting some of the GPU time to just show nice things on the screen, which is probably not what you want to do. Okay, so this is the FC6410. So this is the first platform that we have added support for in our release. We are planning to add support for other Snapdragon 600 platforms soon. But basically, I keep mentioning that this can be used as a desktop. So how do you use that as a desktop? So it's simple. You just get the board, you get a screen, you get a keyboard and a mouse, and that's basically your desktop. As I said, there is onboard eMMC. Sometimes this is not enough. So what you can do is you can add additional SATA drive, for example, to the board. So that starts looking like a PC, a small PC, but this is a PC. Of course, you can debug. You have the typical thing that you would find on the embedded side, Ethernet, serial, and your laptop. So this is the typical setup that you would use, and if you buy this board and if you set up your working and development environment, that's very likely that your setup or your desk is going to look like this. I mentioned that because this is, again, unusual. If you are used to working on mobile applications or Android, I mean, this is not like a typical setup, so at least this is what you would expect. So I mentioned that we are working on the distribution side of things with Ubuntu, but we also work on enabling graphics and multimedia acceleration. So this is a diagram of the graphics stack we are using. So right now we've been using, you might know or not, but there is an open source initiative to provide a GPU driver for the Adreno from Qualcomm, so which is called FreeAdreno. So that's what we've been using in all our release so far. It's actually working quite fine for all the use cases that we've been working on so far. So this is a complete open source. It's a reverse engineering project, and it's available online. I mean, you can just Google that. And that's at the heart of our release. We are planning to deploy and to start using the proprietary driver from Qualcomm, so which will be available soon in our release, and you will be able to use one or the other, and to some extent you might even be able to mix and match the two sets of the drivers. This is a typical X-based stack with the X server and the X video driver. So we use the latest, the FreeDreno is a Gallium Mesa driver, so we use the latest Mesa release in our release, and we keep upgrading to get bug fixes and performance improvement. On the multimedia side of things, so today, if you take our release, we don't have support yet for hardware acceleration. So if you play a file, okay, this is a GStreamer pipeline that shows you how a file is being played on your PC, on your board, sorry. You are going to decode the file and to demux, and you are going to enter and to use the, for example, the libav software decoder libraries. So what we are working on as we speak, actually, and that should happen very soon now in one of the next two releases, we are going to replace the software decoders and the software element in this pipeline by acceleration, which is going to be provided by the video core. This is something which is actually working now to these days, and we are polishing that before we can actually release. It's all available, it's all open source, so you can start playing with it. It's not just yet included into the release. So basically what this gives us is we have complete acceleration when we decode the video. You can play 1080p video playback, and you have zero copy. I mean, you don't have any CPU intervention, so the CPU load is very low. You use the video core to decode the video and the GPU to render and to display the video on the screen. Finally, developer workflow. Again, this is saying that because this is very unusual. People are not used to that. But Ubuntu is a binary distribution. So what does that mean? Everything which is available in Ubuntu is binaries. So you don't actually build Ubuntu. So you don't build Ubuntu images. When you actually build, you don't compile. So building an Ubuntu image means taking binary packages which have been made available to you, either into the Ubuntu archive or to some other place, and you assemble all the binary packages together to pull and to build an image. So that's what we do. So nobody really rebuilds completely all the source code from Ubuntu. It is possible, it's open source, so all the software is available, but nobody is actually doing that. Each packages, each library, each application that you are actually doing is available as a single package that you can take and download and build individually. So that's the feedback we've got from the people who started to use our release, is that they are not used to this working model, and so that's why I mentioned that today. So you get your desktop environment, your build environment ready on the board, and you just start developing. You can even edit the files and compile. It's much easier, in fact, to compile natively what you have to build than to just set up some complex system to cross-compile the complete system. All the Linaro content that we produce is, of course, open source and publicly available, and is available on Linaro dedicated PPAs on Launchpad, which is the system which is used to manage the Ubuntu. So I give the name here. Okay, so I've talked a lot about Ubuntu. If you prefer to build your own system, if you really want to get into do it yourself, and if Ubuntu is not the right platform, and there are, of course, issues that can, I mean, it could be a problem to use Ubuntu at some point. Ubuntu is not meant to be a very small, you cannot really build very small, tiny images. So for the embedded space, or for the very embedded space, maybe Ubuntu is not the right answer. So there is something which is called the Octo project, which is a set of tools that you can use to actually build your own system and your own distribution, and that can be as small as like a couple of megabytes, for example. So we've started to add support for to help this community to build their own open embedded based images and product by adding by providing the recipes and the basic content to enable the Snapdragon. So the demo that you are going to see next is actually using these instructions and open embedded, and they are going to talk more about it. So we have enough support to get you started with open embedded, and we are planning to keep on and move and continue the support. Finally, the last problem I mentioned, if you remember in the problem statement, was the upstreaming of the kernel. Using an unchained kernel is not something which some of the embedded developers want to do, and there is a large, growing community of people who are trying to address this issue. So there is a community of people, whether they are Qualcomm developers, customers, people in the community, people from Linaro that are actually trying to address this issue and close the gap and make sure that the Linux kernel.org release work fine on these platforms. So this is a huge effort. This is a huge development effort, and that has been growing over the last few years and few months, and we are contributing and participating to that with our engagement with Qualcomm. How do you get in touch with this community? Again, it's an open source community, so there is a mailing list, there is RSC, and that's how you get in touch. What we do is that to make it simpler to get started, we maintain what we call a tracking branch. So there are many people who are actually developing drivers and support for the Snapdragon. They send, I don't know if you know how it works, but they send a patch on the mailing list and people review, and this it can take time. It can take something like 3 months, 6 months to get your actually work included into the kernel. So what we do and what Linaro is doing is we actually look at all the development which is happening in the open source, and we take all the patch that we need that improve the support for the platform, and we maintain that into our own version of the Linux kernel. We do this work every week. Every week we rebase on the newer kernel version, and we are always based on the tip of the kernel development. So our branch gives you access to everything which is in mainline kernel plus everything which will be in the mainline kernel in the next 6 months maybe. So as of today, as an example, this is a solid baseline for you to get started. If you start with mainline, you have very few peripherals that work. If you start with our branch, you get like USB, things like USB, Ethernet, SATA, that display as well, that works, and that gives you a better platform to actually start working. So this is, I think, the end of my presentation. I'm going to Krunal, to let Krunal continue the discussion. The last thing I want to mention, so I have mentioned that we've been working with the FC6410 and with the Ubuntu build. As of starting next week, you will actually be able to, when you buy and when you order this board, to have the option to choose between getting the board with Android on it or actually Ubuntu, the release which I've mentioned. So this is the work we've been doing over the last 6 months, and this is just the beginning, and we are going to continue this work. Connor?
Thank you very much, Nicholas, for sharing this wonderful bunch of information. Now, let me start with a quick introduction. So, eInfochips is a product design company with more than 1,200 engineers and 10 design centers across the world. We provide end-to-end solutions right from concept and design till sustenance and re-engineering of the product. We provide solutions to various key verticals like avionics, medical, health, security and surveillance, etc. Now, at the same time, like we provide solutions right from the ASIC till application layer. So we have a bunch of engineers, who can work on the Android and Linux platforms altogether. Now, coming back to main agenda of this session, like I will talk about the video conferencing solution that is developed by eInfochips on FC6410 platform, which is based on the Snapdragon 600 SoC. In the later part of the session, we will see the live demo, which is set up there, right? Which it's a video conferencing solution. Like you can just compare it with the Skype, but it's running on the Ubuntu-based embedded Linux. These are the major software blocks of the application, wherein you can see the Open Embedded based Linaro release. We had added support for V4L2 based capture, which captures the video over USB, and the Sophia SIF, which is used for the call session management and sending the data over RTP. We have a integrated Qt5, which is using X11 plugin for the graphics rendering. Now, this is a typical setup for any video conferencing solution, wherein you can see like we are using the FC6410 as a desktop PC. You can see there is a USB camera connected, keyboard, mouse, and of course a display panel which is connected over the HDMI. So basically one end, let's say the point A place a call to point B. So as soon as the point B receives the call, we start the audio video pipeline using GStreamer, and the rich GUI, which is application, it's basically displayed using Qt5 or the X11 server. So now after looking at the top level availability of the application, let's see what is there inside the box. So as you can see, there are 4 major parts of this application. One is Qt5 Web UI, media encoding pipeline, media transmission pipeline, and media consumption pipeline. You can see like the flow of the application starts from the video capture, wherein we capture the video over USB. We give that part to the GStreamer encoding, which is right now it's a software based, so we support 640 480 resolution as of today. But yeah, we have still scope of improvement there. As soon as we receive hardware codecs support, we'll be embedding that and we'll be able to achieve 1080p resolution with that. At the receiving end, we have a decode module which receives the RTP packets, decode it, and just display it over the HDMI. At the same time, we have a local preview which captures data over USB and display it on the HDMI panel. Now, how this application is built. So, as Nicholas has said, like they provide Ubuntu-based images. So on top of that, so we have used Open Embedded based release, which uses bitbag for the compilation procedure. So we took that package from Linaro website, we downloaded and we added support for V4L2 based capture because it was not available there, and since we wanted to have a video conferencing application, we need to have video capture there. So we added that V4L2 based USB based V4L2 capture support. We built our own file system from the Ubuntu source code or the release which provided by Linaro. We added X11 support in that, and we hook up a plugin with Qt5 so that we can use the OpenGL part of the processor. And then we have so all this Linaro and Open Embedded based development is done using the recipes. So similarly, like the proprietary firmware which are available from Qualcomm are part of Meta Qualcomm recipes. Similarly, we have built our own recipes called Meta Info chips, which includes Qt5. We have our own VC application as a part of that recipe, and of course the Sophia SIF, which is used for the session management. Now after doing this, still like we are struggling with the performance a little bit. So what we have done is to achieve that performance, we have removed the GStreamer plugin from Qt and we have used direct GStreamer APIs, so that basically we have bypassed some of the layers so that we can remove that latency in the software. In addition to that, we have used GL image sync for the graphics rendering, which makes the graphics basically divert some of the part of the graphics to the hardware coprocessor. And with this, like before doing this optimization, we were getting 70% of CPU utilized, but after this we were able to boil it down to 25% of CPU and even less than 50 millisecond of the latency, which I'll be showing it to you on the demo. Okay. So let's see like how the demo is working. So yeah, so you can map this setup with this picture shown here. So I have endpoint A and endpoint B. So you can see it's most of it's a desktop PC only. As Nicholas said, it's a small desktop PC where I have a USB camera connected. I have a keyboard mouse for entering the data to the application, and this is FC6410 board which has all the connection going in, and a HDMI which is connected to the TV. At the same time, we have audio connection, like both audio in and out, and the same setup is replicated at the other end. So now what I'm going to do is I'm going to place a call from this device to this device, which is having the IP address of 10.99.7.80. Right now it's a point-to-point communication, but with the Sophia SIP we can still have multi-party conference, wherein we can have conferencing. So 3-party conferencing, let's say. So 3 parties can call each other and can have a conference. So let's just place call from here. So as you can see, like on the endpoint A, it shows placing a VoIP call to the other end. Here you can see the ringing. As soon as I accept the call, the GStreamer pipelines are initialized, and you can see the live picture going on here. So this is a 640 480 resolution running at 2 Mbps, and you can see the latency is like it's very low. So right now, as I said, these are using a software codecs, but once we have the hardware codecs integrated, we'll be able to do 720p at 60 fps and even 1080p at 30 or 60 fps based on the SoC power. At the same time, the graphics UI which you are seeing right now is based on X11 server. So we are not utilizing the capability of the SoC, which is Adreno processor. So what we'll be doing is we'll be adding support for EGLFS or Wayland. Through that, we'll be diverting the graphics part on the co-processor so that CPU can be freed for the other work, and we can utilize the CPU better. Yeah, so that's it from my side. If you have any questions, feel free to ask.
And so we have plenty of time for questions. Remember, if you have a question, there's a microphone, so you can ask questions from any of the panelists. Should we bring some coffee for you?
Well, I have a comment.
There is one question. One question.
Oh, would you mind asking? Maybe nobody wants to get up and I should take them.
Come on, Leon, do some more.
Hi. So you mentioned that. Am I audible?
Is it on? I don't think the mic's on there.
Yeah, you mentioned that you provide.
Sorry. Let me start.
Can you?
You said that you provide a Gnome shell built along with Linaro Open Embedded Linux. So is there any reduced, like a stripped down version of Gnome that you provide?
What do you call stripped down version of Gnome?
Because the Gnome shell is somewhat performance.
Yeah, so basically, yeah, so the question is, I mentioned that we provide the Gnome shell environment, and the question is, do we actually provide a stripped down version of this environment? So actually, we provide the stripped down version of the Gnome shell environment, which is actually requires 3D acceleration and so on. Everything which is available in Ubuntu actually will run. So if you can actually just install XFCE, LXD, you can install any other OpenBox, Metacity, any other application or window manager which is available. We could not just make images for all of them, so we just pick one which is nice looking and good enough to show. But yes, you can install anything which is coming from the Ubuntu archive. Any standard application using GL, GLES is going to work, like games, for example.
And if you want to run minimal, you can use Chapter. I don't think it's working. No, I don't think it's working.
I
You wanna
just
go
make
up
a
on the
comment
stage?
here. No, it's okay. Just wanted to let you guys know I'm from Qualcomm Snapdragon team. My name is Keto Gandhi, and I've been working with the team to do some of this enablement. So we've made quite a bit of progress in providing Linux on Snapdragon 600. So starting next week in Force Computing, they're also here. They have a booth at Uplink. They are starting to ship FC6410 board, the one that you saw the demo on, with the Linux pre-installed on the board. So you would have the option of either picking Android or Linux, and they would ship the board with either of the two. So that's starting next week. That FC6410 SKU with Linux is available. You can get more information from their website if there is interest.
I guess, we have a list of
So for the camera, obviously any USB camera will just work, but I guess that's not the question. There is Enforce, for example, if we take the example of Enforce, they actually sell camera boards that you can buy on their website. So these are the cameras that we are going to support. Sorry? They have YUV sensors. So the one which you can buy right now is the 5640, and they are going to switch to 5645 from OmniVision soon.
I don't know if I caught it, but is there a Wi-Fi chip or a BT chip that's on the board?
Yes, there is. So there is the QCA6234, which is on the board, at least on the FC6410, which is working, which is enabled. So in the release, it's there.
Does the image, Gnome image, allow me to run in the headless mode without the GUI?
Yes. That's why we actually provide two images. We provide the developer image, which is headless, so there is no X server, for example. You boot and you don't never need a display, and we also have the Gnome image to show with the display. But even without the display, you can enable the Wi-Fi. From the command line. Yes.
Your question on the Wi-Fi stuff. Is there any controls to move the frequencies down into different bands?
I don't have the answer for that. I don't know.
We support both bands, 2.4 and 500. Is that the question? Was that the question? Do we support 2.4 and 500?
No, we're looking more for like on the safety, quick 40 to 41. So a lot of the Aero safety is slowing down the frequency band. Just curious what kind of control we have.
Well, there is the driver which we use for the Wi-Fi is just the mainline driver, which is in the mainline kernel. So if it's a feature which is there, it's surely going to work. I just don't know. If the feature is enabled at the moment. Any last question? Yes.
Hello. Does the Ubuntu image support frame buffer?
So we use the KMS driver. So it's, yes, you could if you really wanted to use the frame buffer interface. But we actually, all the image, if you use Gnome shell and the graphics acceleration is going to go through a DRM KMS driver, which also provides frame buffer, but that's less optimized. You could run, for example, the QD5 demo could run on just the frame buffer if you wanted.
No more questions? Okay, let me wrap it up. By the way, I saw Chad Sweet in the audience, and some of you may recognize him. He was on the stage during our CEO keynote, and so happens that the board that Steve Mollenkoff held at the end that was used in that demo is actually the same board. So there's a lot of things that we're enabling using that board. This was just one example. There's also robotics is another area which I think this particular processor as well as the board, especially the Linux, Ubuntu Linux is going to be very, very important to enabling.